Good afternoon, everybody. So today we have the pleasure to have a talk by Professor Jacobus Swart, that now is representing IMEC in Brazil. So Jacobus has a large CV of achievements. So he is a IEEE fellow, and he is also level A1A in CNPq, and he's now a former professor of the University of Campinas, and so he has a large experience also in international cooperation. So I'm not going to tell all his CV. You can see more details in the flyer, and he has more than 300 papers in journal and conference. So very important set of achievements. So it's a pleasure to have here today Jacobus to talk about IMEC, that is a very nice and important research center supporting the industry evolution, not only in Europe, but also in the world. So thank you very much, Jacobus, to accept our invitation. Then I give you the Jacobus to do your presenter, to share your screen and start your presentation.
Okay, good evening to everybody, or good morning, or good afternoon, depending on where you are. Thank you, Ricardo, for inviting me and giving this opportunity to talk about IMEC. So since 2013, when I retired from the university, I took this job to represent IMEC in Brazil. And wait a moment. And I have followed IMEC since the beginning, because before IMEC started, I worked at the university, Catholic University of Leuven for 2 years as a postdoc, just the 2 years before the start of IMEC. So I saw this when it started and followed it since then. So I will talk about IMEC supporting institution to industry evolution. The mission of IMEC is, it aims to be the world's leading R&D and innovation hub in nanoelectronics and digital technology. IMEC was started in 1984 as a spin-off from the University of Leuven, together with other universities in Belgium in the region of Flanders. Also, the word IMEC, the name came from Inter-University Microelectronics Center. So that's how it started, to be a center of integration with the universities and joining efforts, working together. It is located at the campus of KU Leuven, at the corner. You see here the campus with where it started here in this building, and this was the building of the clean room. And then it expanded over the years. Today we have here, this is a pilot line with 200 millimeter wafers. In front of it you have organic solar cell line for organic and inorganic. So they work on solar cells, both organic and silicon. In front of that you have, wait a moment, let me remove this. You have a nano biolab And in the back of the other building here, a neuron lab, because they work in bio and neuro with hospitals and for biomedical applications. And here in front of that, this bigger, large building is a 300 millimeter pilot line. And in the back of it, you see a tower, a special form of tower, attracts your attention when you come on the road from Brussels, for instance. This is an icon when you enter Leuven. So that's the last building that is added. IMEC is a network of formed a networked innovation model where they put together and make joint research with companies that were material suppliers, equipment suppliers, fabless and fablight and ADA tool providers, IDMs and foundries, and also system partners. So there is a network working, doing research in a collaborative way with different companies on forming what they call core partnership on a certain project. So even competing companies join together to work in a non-competitive way, in a phase, the first phase that's non-competitive, to develop initial projects. And later on, then each one brings the results to their own company where they develop it further on their own specification. So that are the different players all together in one site, IMEC. Why are they working with IMEC? What do they get? First, they get access to our state-of-the-art infrastructure. So IMEC has state-of-the-art new infrastructure, always renovated and updated. What they don't have at home, many companies don't have that at home. They could have similar things for production, but not for research. So here they can benefit from this advanced infrastructure just for research, for development and research. Also, they benefit from a large international network of expertise under this roof of IMEC. They enhance competitiveness with our in-depth technological knowledge and lower the research and cost and risk in this research, in this pre-competitive collaboration, and accelerates your product development, your product roadmap to reduce your time to market. This is done with a large team of 4,500 high-skilled researchers. These researchers are from many different nationalities, more than 95 nationalities. Maybe about 50% of them are from Belgium, are Belgian citizens. And the second one are Dutchess, people from the Netherlands, 260. And then you have others like from India, from France, China, Italy, Japan, even Brazilians. You see here 19 Brazilians. However, this number should be much higher or considerably higher because many Brazilians have double nationality. And if they have an European nationality, they register as Italian or Belgian, or German. Or for myself, I am also double nationality Dutch. So the paperwork is much easier when you have an European passport. So that's why these numbers should be higher. But from Latin America, there are others, from Colombia, 15, Mexico, 10, and so forth, Argentina. So there are people from many countries here also in the region. About revenues, this is the evolution of the revenues of IMEC, starting maybe in when it started in '84, maybe around 10 million euro, and now last year it was 640 million euro. Every year there is a growth, except you see here 2009, there was a small reduction because economical crisis in the world, and afterwards it grew again, especially the last years, because some years ago we joined with another entity called IMEC, which was also a non-for-profit organization funded by the government of Flanders. So that's the evolution. Splitting up this budget from last year, you see 72% of this budget comes from industry. So IMEC is strongly related, working together with industry. Then you have 9% about for funded projects, and 19%, which corresponds approximately 220 million euro, comes from the regional government. So there's a grant given by Flanders to help to produce results in benefit of the society, of Flanders society. If we compare that with some other institutions here in Brazil, for instance, the University of Campinas, for the whole university, the budget is about 400 million. So IMEC has 60% more than Unicamp as a whole. Or if we compare it to CETEC, that has a budget around 12 million euro. That is 1/10 of what the grants given by the government of Flanders. Remembering Flanders has a population of 6.6 million. So that's not much what's expended here in Brazil, if we compare to Brazilian. So what the Flanders community expects in benefits of the community is knowledge, publications, spin-offs, jobs, and educations. So the IMEC, the application of patents were 160 last year, about 2,000 publications. Spin-offs were 6 new spin-offs last year. Over the 36 years, it were 118. Also, 26 new startups were selected from an accelerator program called IMEC Start. So this is all in benefit of the local economy and society. For academy, as we said before, we have more than 700 PhDs working, developing research, but IMEC is not an academic institution. So they defend their thesis at one of the 5 partner universities in Belgium. Also, we have more than 50 postdocs also related to these 5 universities. IMEC is located in Belgium, Leuven, the headquarters, but we have also centers in other sites like Eindhoven in the Netherlands, more recently also in Wageningen, where the center is called One Planet Research Center, I will talk more about this later on. And also in Orlando, USA. So Florida realized that it is not good having their economy too much dependent on tourism. They also wanted to have more high-tech companies there. I think the coronavirus shows the importance of having more activities than only or mainly tourism. So they invited and give, like in the Netherlands, the Wageningen, and in Orlando, that are local initiatives that promote the center, give some benefits and facilities to install a new center. We have an engineering team in Taiwan, in Hsinchu, and also other offices or business development sites in Japan with some engineering, but are smaller groups in Japan, Tokyo and Osaka, Shanghai, Bangalore in India, San Francisco in California, and also in Berkeley, where one professor is also vice president of IMEC. Jan Rabai, many of you know. He is professor, retired professor, and has so double hats, two hats, one for IMEC, and he still has his students in Berkeley. And here in another color is Campinas. For myself, it's not actually an official center for IMEC. I offer consultancy work for IMEC. I represent IMEC, but it has no tax number, for instance, in Brazil. It is not an official site. In Belgium, the headquarters are Leuven, this campus I showed before, but we have also sites in Brussels, is an EU hub, and a center in Ghent for smart application, one in the left here in Kortrijk for smart education, and in Antwerp for City of Things. And the 5 universities, KU Leuven, University of Hasselt, Free University of Brussels, and University of Antwerp, University of Ghent. That are the 5 universities that are partners of working together with IMEC. So that's a general overview of IMEC, and now I will focus more on what are the main activities, R&D, innovation, and venturing. For R&D, there are 2 models. One is in core partnership for many different projects, and the other one is for research on demand. So just for one company, a specific project doing together. And what are the topics? The big one, the very important one, is core CMOS. So if developing the new generations of the new nodes for CMOS, that is in some nodes that will be in production in 2 or 3, 4 years. So that's one subject. The other one is for sensor technology, all kinds of sensors, flexible electronics, flexible technology. So that are the semiconductor and system technologies. In parallel, we have the digital technology platforms. So networks of things. Very important one is also digital privacy and security, and software data management skills. And that all, these platforms aiming applications for smart health, smart mobility, smart cities, smart industry, smart energy, smart education, smart entertainment, and so on. And in addition, we have the services units. One is for training, another one for innovation services, and third one, venturing. So I will give some flavor, some examples of research projects that are going on. These as innovation platforms. So I'll first, based on microchip technology, the basic processing steps, techniques, tools. On top of that, we have the technology platforms, logic CMOS, memory, 3D, heterogeneous integration, photonics, MEMS and microfluidics, sensor platform, flexible technologies. And in parallel to that, the digital technologies platform is like artificial intelligence, privacy, cybersecurity, 5G networks technology. And on top of that, the system platforms like neuromorphic computing, beamforming platform, DNA sequencing, nanofluidics processor, cell sorter, RF technologies for 5G, wireless sensor hub, quantum computing, lens-free imaging, hyperspectral imaging, solid-state batteries, solar cell systems, and others. And that all for these applications I mentioned before on top of that. So for core CMOS, the aim is always develop new generation, new nodes where we seek for smaller transistors, higher density, faster transistors, consuming less power. So that's the main driving force for this, following this path and this roadmap. So CMOS, IMEC followed the roadmap and advanced the roadmap since the beginning, starting in '84, probably with 1.5 micron, as far as I remember, because before at the university, Leuven developed 2 micron, and that was transferred successfully to companies in Great Britain. So that was the basis for next generations done at IMEC. Following from this 1.5 until today to sub 5 nanometer nodes, with all the steps involved in developing such nodes. Now, starting in the beginning, or the main roadmap was on planar transistors. By the 22 or 20 nanometers, it was shifted to FinFET technology. And now, after the 5 nanometers, we are obliged to go to new structures because of the off current. Is not enough with the FinFET. So it needs to be lowered, and that can be done by gate-all-around structures. That could be a wire or a nanosheet. So what we are doing mainly is the nanosheets of transistors stacked one on top of the other. So we have a nanosheet for P channel, nanosheets for N channel, forming the structures of the new transistors that will be the basis for 3 nano and below. And for that, you need to develop the materials, the technology, all this base processing, the process integration, also modeling and reliability. Reliability is also a big issue that needs to be taken care of. So for this, on that, they have developed the different platforms for CMOS logic and also memory. Many new memory concepts are developed. Are all developed and tested and can be basic knowledge transferred to, brought to the partners, the core partners that are participating on this initial research. One other big issue is patterning. So for making, going deep into nano nodes, you need new extreme UV lithography. So ASML, that's #1 company in lithography tools, located in the Netherlands, and that is a strategic partner of IMEC, where they do the technology development together with IMEC. So they bring their tools to IMEC and they work on it together, and together with future users, companies that will work use them afterwards in their fabs. So that's now already in the industry. It is being used in the industry. This is a wavelength of 13.5 nanometers in that order. So that's a new, very expensive lithography tool, very critical for the new nodes. Besides planar technology, we need also integrate different technologies and increase packaging, the density, and that can also be done by 3D integration. So stacking chips one on top of each other, integrating a system in this way. So these chips can be of different technologies. You can optimize each function on the appropriate technology for that function. Another new and important technology, that is photonics, integrated photonics, integrated circuits on silicon for communication systems, communication between boards, and also communication on chip. So all kinds of communication. This is important. This technology has future in these fields. But besides that, also for medical applications, as many kinds of sensors can be made on photonic ICs. So that's also an important field. Another example of technology that is being developed is the flexible electronics. That is electronics fabricated on plastic. So that is very cheap and can be produced in large quantities, where you can integrate displays, you can integrate electronics like memory or some logic, tags, and so on, sensors. So there's a new field that's also very important for many applications. Future quantum computing, many people are studying, and IMEC is also working with a group on quantum computing, starting with superconducting material, but also in qubits in silicon. Qubits in silicon is better scalable and more appropriate, and probably. So that is also basic research and technology research on this field for future integrated circuits. Neuromorphic computing, that's another application, a new field of computing, way of computing. that's more like computing like human brain, so mimicking the human brain with algorithms, with logic, physiologic, more intense physical logic than in normal silicon computing. And in this way, they can compare to deep learning with a GPU, for instance, you reduce the power consumption 10,000 times. So it is a way of reducing very much the power consumption. Like in our brain, we process many things with very little power. No, my head is not warm like yours. Nanofluidic processors is another field, another example, where you can integrate in the circuits nano channels, microchannels, micro valves, mixing chambers, and so on, and do many functions for biology, for medical applications, chemistry, and so on. And as one example is a cell shorter. So we can, for instance, select cells in blood, as an example, identifying the cells that are cancer cells from the others, and separate them, sort them with the microfluidic channels and valves, selecting with optical identification. You select and send them to one channel, so shorting them according to the classification as a cancer cell or a normal cell. If you put thousands of them in parallel, you can sell up to 20 million cells per second. So it's a very powerful tool. Biomedical sensor SOC platform is one other example of research and development, or IoT sensor node, that is very small, cheap, intelligent, very energy efficient, other projects. Or the, as I mentioned before, hyperspectral imaging. So IMEC developed hyperspectral imaging imager with filtering on chip. So the wavelength is selected by filters on the chip, and you select different filters for different spectrum you want to detect. And that can be used for grains, analyzing grains, or as in this picture, but also analyzing soil, analyzing plants, fruits. And it can be very compact. It can be mounted on a drone, for instance, and you can fly through the fields to identify diseases and the characteristics of your plants. Health is a very important subject for diagnosis. You can have patches with different sensors to identify the health condition of a person and monitor him. Connectivity is another important field. Connectivity is for the whole spectrum, since Wi-Fi to 5G to radars. This one here in the center is for a radar at 69 gigahertz. So our communication with different spectrum frequencies. City of Things, Internet of Things. So our center in Antwerp is a smart city lab, the largest smart city lab in Europe, where they have all kinds of sensors spread over the city monitoring air quality, weather conditions, traffic conditions, and also, for instance, utilities, and so on. Also water management, because Antwerp is also at sea level, like the Netherlands, where you have a lot of water. You need to manage the water to avoid flooding. So that's the largest smart city lab where they develop Internet of Things, smart cities. Virtual and augmented reality, also devices for that, like these eyeglasses, including OLED device, OLED display, eye tracking, and many sensors for these applications. Since the beginning, IMEC worked before also on power energy, solar power energy, photovoltaics, on both organics and inorganics, including the area of building integrated PV, so on. So that's an important, and in addition to that, smart energy systems, or smart storage, energy storage, solid state storage, and so on. Smart mobility is another field of research and development. So the driverless car, very important for the future, or starting to be, where the cars need to avoid the traffic needs to be optimized, avoiding any collision with a pedestrian, with a bike, or with other cars. So the car needs to have a lot of sensors, for instance, a lot of cameras, also in the visible, but also in the infrared, radars for many different distances, for 30 meters, for 50, for 250, the LiDAR, GPS, ultrasound for very short distance. So it need to be equipped, and we need to develop these devices, these sensors, with beam, optimizing the beamform appropriately. This is an example of the 79 chip of these cars. Besides, the car also needs to combine, so it needs to do sensor fusion. It needs to take all this information from all these sensors, in addition to information from other cars, in addition to information from the cloud, process is all in order to optimize the traffic and avoid any problem, any collision. So it's a very active area of research. Smart agri-food, as I mentioned before, the province of Gelderland in the Netherlands, where this University of Wageningen is located. Wageningen University is the #1 university worldwide in agribusiness, agro engineering and science. And in addition to that, also is involved the Radboud University and Radboud Medical Center. So together, this province stimulated to form a new center involving with the participation of IMEC to develop technologies for agro application, precision agriculture, and precision health. So they gave benefits and promoted to form this new center. That's something 1 year old now. It's very recent. So for research in precision health, nutrition, behavior, all to benefit the health conditions of the persons, of the people, optimize precision agriculture. You see here the landscape of a typical Dutch area with the cows, but that is much more than this. So that's another important field. There was, as I mentioned before, one center devoted to smart education in Kortrijk in Belgium, where they develop tools for schools, for kids, for teaching basic schools, but also for higher level education, as we see here, modern tools for improved teaching. And IMEC itself also uses these techniques when we offer courses. So one service is to offer courses on all kinds of knowledge that was developed at IMEC. For instance, IC design, CMOS technology, energy, and so on. So we also offer as a service these courses. So, as I told, we gave many examples of R&D in collaborative or on demand. Second branch is innovation services. So we will talk more about innovation services now. We have a team that offers service to assist customers in this way to help them to accelerate their innovation and reducing the risk for this innovation. So bringing one idea to prototyping to production. Our team is composed of about 200 people for IC and for board service specialists. This is not research, so this is not related to the research groups we described before, but we do service to these groups sometimes. So in many cases, when they need a special IC or a special board, we provide assistance and service to this research group. And this service is done in an industrial way. So we follow standard industry methods and flows. Yeah. For ICs, services to assist ICs, products and systems, and prototyping, system prototyping and test beds. Moving. Within these 200 people, there is one, the largest part is called IC-UNK for ASIC customers. ASIC customers, what do they need? They need some guidance first to access the right ASIC technology. So depending on your application and on the market size, on the performance, you have to select correctly your ASIC technology, the technology node, so that we can give a guidance to that. You need prototyping at low cost. You need pre-series for engineering support, including assembly, testing, qualification. And the third phase, you go to volume production. You need supply chain and product engineering, like yield, control, failure analysis, and so on. So we can assist in all these needs for a customer. Who are the customers? The customers are academia, R&D institutes, and industry. All these three. inside IC-Link service, we have the EuroPractice program. The EuroPractice program started for university, but was expanded also to other industries, This started in 1889, when EuroPractice started. At that time, we had 3 partners. IMEC was the leader, and then we have 2 partners, Fraunhofer and UKRI in England. Fraunhofer in Germany and UKRI in England. So these 3 offered this program, services through this program. This program was renewed with support it had always support from the European Commission, and it was renewed last year, and we added 2 more partners, CMP in France and Tyndall National Institute in Ireland, right? So through this program, we can offer services by foundries. You can access foundries like these, all these ones, AMS, TSMC, UMC, Global Foundries, on Semiconductor, XFAB, EHP, ST Microelectronics, EM Microelectronic, and Global Foundry, I mentioned, I think. So you can choose any of these foundries to make your ASIC. For electronic ASIC. And now for photonic ASIC and MEMS, we have other foundries. IMEC itself has a pilot line, Leti in France also, EHP, and advanced micro foundries. And for MEMS, we use the foundry called MEMSCAP. So this is all offered through EuroPractice program. But in parallel, we have a special agreement with TSMC, IMEC. So we are VCA, value chain aggregator for TSMC since 2006. TSMC has 8 VCAs in the world, and IMEC is one of them now since 2006. But before that, since 2005, TSMC was already a core partner for the advanced CMOS technologies. So it participated in the research groups also. Now for the service unit, we are VCA. And since 2013, we are exclusive VCA for Brazil and Latin America. Important to note is also that in 2015, Maurice Chang was the founder of TSMC in 1987. He invented the model of pure foundries. Before that, there were no pure foundries. So he invented this model and founded TSMC. And nowadays, TSMC is the most advanced fab in the world, and it has a market share of more than 50% of the foundry services. And so Maurice Chang received an award from IMEC in 2015. So that's recognizing the importance of his work of TSMC to the world and to IMEC. IMEC is a partner, VCA partner. Through this, we can assist customers for innovation, to bring innovation to market. Through that, you can access a full portfolio of the TSMC technology. We have as a VCA, preferred pricing. You can have scalable volumes, small volumes, medium and high. IMEC is, as a whole, through this partnership, is customer number between top 10 customers of the TSMC. And we are VCA number 1 in the number of tape-outs worldwide. So in addition to that, We also offer other value-added services like design, IP access, assembly, testing, and qualification. Here you have a portfolio for TSMC technology you can access through the VCA program. For logic, you can choose, for instance, from over 50, half a micron up to 5 nanometer technologies for logic. But you can also have specific technologies for analog, RF, high voltage, BCD, power ICs, embedded for non-volatile memory, imagers, and MEMS. TSMC has a large number of fabs, most of them in Taiwan. They have one in China, Fab 10, and Fab 11 in the US. And some affiliates in Singapore. And they have also some backend fabs. So a large number, and some, the Giga Fab 18 is still under construction. TSMC invests capex over $10 billion per year. So that's very enormous quantity of capex they invest in technology and in capacity. What are the technologies they get the most revenues from? That changes along this for the quarters in the 2 last years, up to 1 year ago. You see that node 7, the purple one, is increasing, and over 25% is for 7 nanometer already. So the higher end technologies are responsible for a large part of revenue, not in the number of wafers, but in the revenues that are very expensive wafers. There is a BCD, is a specialty technology for high voltage, very important for automotive applications. There is a roadmap. Here you have generation 2 for 0.18, generation 3, 0.18, and then you have a 0.13, then you have 0.18 on SOI, and now they are introducing in this quarter the node 25 nano BCD plus E-flash on SOI. So that's also an evolution roadmap on this high voltage, because there are many applications, especially for automotive, where you need high voltage. So IMEC assists customers giving access to TSMC, but through a global network, we also assist with assembly, test, design, supply, the whole chain. So for assembly, we have other partners. There are many different types of packages you need to choose from. We can assist on that, help in the design also of BGAs, for instance, and give full support for packaging service with different partners. The same for testing qualification, where we help also with the design for testability in the beginning, during the design phase. And we have different partners in Europe and in East Asia also. There are many steps involved in, as you know, for the design, system design, RTL, synthesis and support, tests, generation, place and route, DRC, tape out, mask, wafer supply, assembly, test, qualification, certification, PCB. So all these steps we can offer in 2 models: as a turnkey, where we do everything, you specify and you get your tested dies. That's one model. some customers ask for that, but in majority choose for custom-owned tooling, where they choose just part of the steps. For instance, most of the customers do the design themselves. The mask making and wafer fabrication is always done by IMEC and Foundry, and the other options can be added, service, or done by the customer itself. So there are different and transparent models we assist our customers. For many applications, you can think of, here they show some of them, medical application, of industrial, space application, consumer, artificial intelligence, and so on. There are many more. One thing I looked for was an overview of where our customers are, where our revenues for this ASIC service comes from. Most of our customers are still in Europe, West Europe, more than 60%. USA and Canada is growing, it's now 20% almost. Then in third, we have Middle East, Asia, especially Israel, Far East, China, Taiwan, Japan, and others. Central and East Europe, Russia is a big one. Oceania, that's Australia mainly. South Asia, that's especially India. And Latin America is less than 0.3% of our revenues come from Latin America, showing, I wanted to show this, showing that we need to do much more for innovation with ASICs. So it's still very little what is done in Latin America and in Brazil in the field of application of ASICs for innovation. So we hope and we believe this can change, it should be changed in future. Last two slides are about venturing. There are two programs. One is iStart. iStart, we select, there is a call for startups. These startups are interviewed and analyzed to be selected. So last year, 26 were selected and giving support in an accelerator program called IMEC iStart. In this program, up to now, we have 198 startups. They created 1,500 jobs. This program is number 4 in worldwide. 25 startups were sold, so this was success. They captured more than 250 million euros by funding by investors. 35 of them are co-founded by female. This can grow, we hope. And they have a revenue of over 120 million. And more than 100% are international active. So there's one important program for Belgium. Many of them are in software. But for Expand, it is important to use, there's another call for spin-offs. That's a different call. And the condition is that they use IMEC IP or technology from IMEC. So that's a condition. So then they give invest in this. They are selected and are supported with business support and advice, and with the technology that is available at IMEC. So last year, 6 new spin-offs were selected, and a total of 118 spin-offs are partners of IMEC, generated in this way. So there is a list of logos of these spin-offs. And with that, we have here a list of our values that are integrity, passion, connectedness, and excellence, and our slogan. IMEC, I think, is a very interesting example. I think that can inspire many other institutions, many other research centers that interact with the market, with companies. It's very successful example, so I think it's very interesting for everybody. With that, I thank you for your attention. I think I made it within 1 hour, but I am open for questions.
Okay, Professor Jacobus, thank you very much. Very nice talk, showing the very nice work that is doing IMEC since a long time. So it's a pity that we don't have something similar in Brazil yet, at least yet. So we have here many people also congratulating you for the talk, but also for the work you are doing, connect IMEC and Brazilian universities, mainly with the mini ASIC program. So like Professor Paulo César Comaceto de Aguirre and Professor Davis Monteiro are thanking you for this nice program. So also I have here a question by José Gabriel Carneiro Gomes, professor in the Federal University of Rio de Janeiro. So thank you for the presentation. And the question is the MINIC ASIC program 0.25 micro and 0.18 micro currently available for Brazilian University? In case it is, how can we access?
To access, just contact me. So all the technologies are available through this through AeroPractice program. It was not clear his question. Does he mean by free mini ASIC or in general it is open? First, just enter in the AeroPractice program. We have a special offer since the last 6 years for to promote activities at the universities. So we give 5 sites, free sites of a mini ASIC, or we select each year 5 new projects by universities and give them free access to basic, that's 0.18, not other technologies, just 0.18. Yeah, for other technologies, you need to access, you can choose anyone in the AeroPractice, but they are paid, of course.
Yeah, but there is a special cost for universities?
It is relatively, there is a special cost for European universities because European community supports partially this program. So they need to give some discount for European universities, but that is a small discount. The prices are very accessible. There's not expensive, depending on the technology node, of course.
The 0.18 microns that is free for the Brazilian university, which is the next deadline?
Yes. Normally it is in December 1st. So we will announce it again, probably near beginning of September, for a deadline in December 1st.
Okay. So if somebody have more questions, waiting for more question, I have also another one. Can you expect to have also a branch of IMEC Research and Developing Center in Brazil?
I think that's not impossible because you see the Netherlands invited IMEC to join 2 universities to set a new center. Florida invited IMEC to set a center. Of course, it is not just an invitation. You need also to give some conditions that make it attractive. Who knows? So education in the world can try.
And IMEC would not be interested to take care of CETEC?
Maybe the ministry can offer it, give a special condition to make it attractive. It is not easy to make it attractive. It should be attractive. I don't know. It's always worth discussing.
Okay, so if somebody else wants to do a question, the last call for question is now. So, well, so I think it's time to thank you, Jacobus, for the nice talk. So
it's a pleasure. Yeah.
IMEC is a really wonderful example, no? So maybe now you can also say some words about chip in the fields next week.
Yeah.
And with a very special registration fee that you define it about some highlights about the program.
Yeah. So first of all, please visit the site of Chip in the Fields. So next week we will start. Normally it would be presential. It would happen in Campinas, but due to COVID-19, we had to postpone or make it virtual. So we decided for some of the conferences that it was postponed, and others it was converted into virtual. So we have 3 conferences that are virtual. That's CDS, what's the name? So the circuit design and WCAS and
SBCCI, WCAS, and
Student Forum. Yeah, and in addition to that, we have also 3 keynote speakers, international keynote speakers from the US. We have 1 mini course on Monday on RF design, offered by our sponsor, Keysight. On Tuesday, there is a mini colloquium offered by EDS and SB Micro. And then start the real conference, the 3 conferences that you mentioned, with 3 keynote speakers and many present papers. The registration is really promotion, very cheap, less than $10. You can register up to the next days and be part of participating to the conference. So we hope to see many of you participating in this conference. And with that, thank you for this opportunity, Reis.
Okay, there is 2 more questions here. So with this, we can close the session. So the first one is from Davis Monteiro. How could we follow the footsteps of IMEC, even if partially, in the Brazilian scenario?
So IMEC of course, success of IMEC is one success of IMEC is due to the quality of people. Second, because the ability of the people that founded it to motivate people to work together. So you see, they first united the universities in Flanders to work together and to set up a center that belongs to all of them. That's one good reason. Second, they motivated companies. They created a model of core partnership to do research together. Even competing competitors are working on one project in a pre-competitive way together. And they are they are attracted, invited by places to set up new centers because of the success of the way of working, how they work. So I think that are some principles that should be followed if you want to set up such a center.
So last question by Mauricio Banazeski. Is there a way to access the PDK in libraries of the technologies like 28 nanometers and 22 nanometers?
Yes, if you have plans to tape out. So it is accessible if you have a plan to do the tape out. So that's important. And there are universities already with access to it, here in Brazil and in other parts of Latin America.
Okay, so thank you very much, Jacobus.
It's a pleasure.
Very
Thank you.
nice talk and also interesting questions and answers.
Good luck.
Thank you again, Jacobus.
Yeah, goodbye.